Alright. Okay, Assalamualaikum. So module 2, single area OSPF version 2 configuration. Right. Okay, single area OSPF version 2 configuration. Okay. So objective of this module, implement single area OSPF version 2 in both point-to-point and broadcast multi-access network. So topic, in this module, we have OSPF router ID, point-to-point OSPF network, multi-access OSPF network, modified single area OSPF version 2, default route propagation, and also finally verify single area OSPF version 2. OSPF router ID. So OSPF reference topology. The figure shows, here, the topology used for configuring OSPF version 2 in this module. The router in the topology have starting configuration, including interface addresses, and there is currently no static routing or dynamic routing configure on any routers. All interfaces on R1, here R1, okay, R1, R2, and also RT in here. Okay, except loopback 1 on R2 within the OSPF backbone area, which is area 0. Okay, here, area 0. In one area. So the ISP router is used as the gateway to the internet of the routing domain. Routing configuration mode for OSPF. OSPF version 2 is enabled using router OSPF process ID, global configuration mode command. The process ID value represents a number between 1 and 65,532. Yeah. Okay. And is selected by the network administrator. Yeah. Okay. The process ID value is locally significant. It is considered best practices to use the same process ID on all OSPF router. Okay, so this the command router OSPF 10, the process ID. All right. When you can see this, yeah, console, and then we write question mark, so you can see all the related command. Okay, in here you can see each of the command, what are the purpose. Yeah. Okay. Okay, router IDs. And OSPF router ID is 32-bit value, represented as an IPv4 address. It is used to uniquely identify an OSPF router, and all OSPF packets include the router ID of the originating router. Every router requires a router ID, which is very important to participate in an OSPF domain. It can be defined by an administrator or automatically assigned by the router. The router ID is used by an OSPF enable router to do the following tasks. First, participate in synchronization of OSPF database. Second, participate in election of DR or designated router. Yeah. Okay. Router ID order of precedence. Cisco router derive the router ID based on one of the three criteria in the following preferential order. The first, the router ID is explicitly configured using OSPF router ID, read router configuration mode command. This is the recommended method to assign an router ID. Second, the router chooses the highest IPv4 address of any of configured loopback interfaces. Third, the router chooses the highest active IPv4 address of any of its physical interfaces. Configure a loopback interface as the router ID. Instead of relying on physical interface, the router ID can be assigned to a loopback interface. Typically, the IP address of this type of loopback interface should be configured using 32-bit subnet mask, which is 255.255.255.25. This effectively creates a host route. A 32-bit host route will not get advertised as a router to other OSPF routers. OSPF does not need to be enabled on interface for that interface to be chosen as the router ID. Okay, here's the example. Explicitly configure router ID. In our reference topology, the router ID of each router is assigned as follows. So we router ID 1 like this, 2 and 3 like this. Use the router ID read router configuration mode command to manually assign a router ID. In the example, the router ID 1.1.1.1 is assigned to R1. Use the show IP protocols command to verify the router ID. All right. Okay. If a router selects a router ID and an active OSPF router does not allow router ID to be changed until the router is reloaded or the OSPF process is reset. Clearing the OSPF process is the preferred method to reset the router ID. That's the only way to do a reset or clearing the OSPF process. Okay. So this is the command, clearing the OSPF process in order to reset the router ID. All right. Point-to-point OSPF network. The network command syntax. You can specify the interface that belongs to a point-to-point network by configuring the network command. You can also configure OSPF directly on the interface with IP OSPF command. The basic syntax for the network command is as follows. We use the network address wildcard mask, area, and what's the ID. Okay, so this is the syntax. The network address wildcard mask syntax is used to enable OSPF interfaces. Any interfaces on router that match this part of the command are enabled to send and receive OSPF packet. The area which is area ID syntax refer to the OSPF area. When configuring single area OSPF version 2, the network command must be configured with the same area ID value on all routers. Although any area ID can be used, it is good practice to use an area ID with 0 with single area OSPF version 2. This convention make it easier if the network is later altered to support multi-area version 2. Okay, the wildcard mask. The wildcard mask is typically the inverse of the subnet mask configured on that interface. The easiest method for calculating a wildcard mask is to subtract the network subnet. Mask from 255.255.255.255. As shown in for /24 or /26. So we use this and then subtract, and then you can get the wildcard mask. Okay. /24 and also /26. Okay, we use this wildcard mask. Configuring OSPF using the network command. Within routing configuration mode, there are two ways to identify the interfaces that will participate in OSPF version 2 routing process. In the first example, the wildcard must identify the interface based on the network addresses. Any active interface that is configured with an IPv4 address belonging to the network will participate in OSPF version 2 routing process. Note some iOS version allow the subnet mask to be entered instead of the wildcard mask. The iOS then convert the subnet mask to the wildcard mask format. Okay, this is the example. All right. Configure OSPF using network command. Continue. As an alternative, OSPF version 2 can be enabled by specifying the exact interface IPv4 address using a code 0 wildcard mask. Entering network like this and the code 0 wildcard mask and array 0 like this on R1, tell the router to enable interface giga Ethernet 0/0/0 for the routing protocol. The advantage of specifying the interface is that the wildcard mask calculation is not necessary. Notice that in all cases, the area argument specify area 0. Yeah, okay, like this example. Configure OSPF using IP OSPF command. To configure OSPF directly on the interface, use the IP OSPF interface configuration mode command. So here are the following command. Okay. So remove the network command using a no form of the command. In order to you want to delete, there is some error. So you can use no. Okay, in Cisco instruction or command, you just use no in order to delete. Then go to the each interface and again configure the IP OSPF command. Okay, so mean here we use no to delete everything. Delete and we do it again. Okay, there is a no like we edit the command. So we just delete that using no command and also we reconfigure. Reconfigure the command. Okay, all right. Okay, this is the examples. Yeah, all right. So passive interface. By default, OSPF messages are forwarded out all OSPF enabled interfaces. However, these messages only need to be sent out interfaces that are connecting to other OSPF enabled routers. Sending out unneeded messages on a LAN affects the network in 3 ways. Okay, first, inefficient use of bandwidth. Which is available bandwidth is consumed transporting unnecessary messages. Second, an efficient use of resources mean that all devices on the LAN must process and eventually discard the message. Thirdly, increased security risk. Without additional OSPF security configuration, OSPF messages can be intercepted by packet sniffing software, like Wireshark. Routing updates can be modified and sent back to the router. And also what happened, corrupting the routing table with false metric that misdirect traffic. Okay, this is what happened. Okay. So configure passive interface. Using the passive interface router configuration mode, prevent the transmission of routing messages through a router interface, but still allow the network to be advertised to other router. Okay, all right. The show IP protocols command is then used to verify that the interface is listed as a passive. Okay, that's the how we configure the passive interface. Okay, all right. OSPF point-to-point network. By default, Cisco routers elect DR and BDR on Ethernet interfaces. Even there is only one other device on the link, you can verify this with the show IP OSPF. Okay, you can verify or we can check again using this command. The BDR or BDR election process is unnecessary as there can only be two routers on the point-to-point network between R1 and R2. Notice in the output that the router has designated the network type as broadcast. Okay, all right. This is the one, and also this is the designated on DR, and also BDR. Okay. All right, to change this to a point-to-point network, use the interface configuration command IP or SPF network point-to-point on all interfaces where you want to disable the BDR or BDR election process. Okay. All right. Loopback and point-to-point network. Use loopbacks to provide additional interfaces for a variety of purposes. By default, loopback interfaces are advertised as /32 host routes. To simulate a real LAN, the loopback interface can be configured as a point-to-point interface to advertise the full network. What R2 sees when R1 advertises the the loopback interface, and it is. So show IP route, okay, pipe include 10.10.1. Okay, and then configure at R1. So using at R1, go to config mode, interface loopback 0, and IP network point-to-point. So result at R2, show IP route, pipe include 10.10.1. Okay, so now you can see this link between loopback and also point-to-point. Okay, so this the activity in order to improve your understanding on point-to-point single area or SPF version 2 configuration. Okay, all right. Multi-access OSPF network. OSPF network type, Another type of network use OSPF is the multi-access OSPF network. Multi-access OSPF network are unique in that one router controls the distribution of LSA. The router that is elected for this role should be determined by the network administrator through proper configuration. Okay, all right. All right, okay. So SPF designated router in multicast network. Okay, so now we talking about multi-access network. OSPF elect DR and also BDR. Okay, the DR is responsible for collecting and distributing LSA, send and also receive. The DR will use the multicast IPv4 address, 224.0.0.5, which is meant for all OSPF routers. Okay, a backup designated router or BDR is also elected in case of DR fail. Okay, that we know. We already know the rules. The BDR listens passively and maintain a relationship with all the routers. If the DR stop producing hello packet, the BDR promote itself and assume the role of DR. All other routers become a DR other, a router that is neither DR nor BDR. DR others use the multi-access address 224.0.0.6 all designated router to send or spare packet to the DR and BDR. Only DR BDR will listen for 224.0.0.6. Yeah. OSPF multi-access reference topology. In the multi-access topology shown in the figure, okay, in this, yeah, there are three routers interconnected over a common Ethernet multi-access network. With this IP 192.168.1.168.1.0. Yeah. Okay. Because the router are connected over a common multi-access network, OSPF has automatically elected DR and BDR. R3 has been elected. RT, this one, has been elected as the DR because its router ID is 333. Yeah, router ID. Okay, which is the highest in the network. R2 is the BDR because it has the second highest router ID in the BDR. This one. Yeah, this one there. So R2 has been chosen as BDR. Okay. So to verify the roles of the OSPF version 2, use the show IP OSPF interface command. Yeah. The output generated by R1 confirm the following, which is the R1 is not the DR or BDR. Okay. Let me check this. Yeah, of course. But it is a DR other, yeah, with a default value of this one in line 7. 1, 2, 3, 4, 5, 6, 7. Yeah, this one. Yeah, you can see. Yeah, is the one. Okay. Next, the DR is R3 with router ID. Okay, at IPv4 address 192.168.1.3, while the BDR is R2 with the router ID 222 at IPv4 address 192.168.1.2. Okay, line 8, this one, 8 and 9. Okay, R2 has two adjacencies, one with the BDR and one with the DR, line 20 and 22. Okay, all right, which is, okay, the next one. So now they come with this. Okay, all right, they come and this is the one. 20 and 22, backup design, and also BDR, also DR. Okay, all right. Okay, the output generated by R2 confirm that when we run this command, show IP interface on interface, yeah, on interface, this giga Ethernet 0/0/0. So here is the result. R2 is the BDR, line 7. Yeah, this one. Say again, line 7. 1, 2, 3, 4, 5, 6. Okay, this one. BDR priority 1. Okay, 7. And then DR is a router, is 3 with router ID 333 with the IP address 192.168.1.3, while BDR is router 2 with router ID 222, yeah, at the IPv4 address 192.168.1.2, this one. Okay, all right. So R2 has two adjacencies, yeah, which is to the next following. In here they said 20 and 20, which is in here. Okay, there are two adjacencies. Okay, with a neighbor router ID 111 and other with the DR. Okay, all right. So the output generated by R3 confirm that R3 is the DR with the default priority of 1, which is line 7 here. Okay. Say again, wait. This one for R3. It's not the one. Okay, it could be wrong. Yeah. This one R1, R2, yes. No. Okay, this one maybe there is something wrong. This one R1. Okay. All right. This one actually R1. Okay, there's some error on this page. Okay, basically they will get the similar info as stated in here. It should be stated when you run at R3. There is some info that will stated in this example. All right. Okay. So to verify DR and BDR adjacencies. All right. So to verify the OSPF version 2 adjacencies, use the show IP OSPF neighbor command. The state of neighbor in multicast network can be as follows: full DR. Okay, other. This is DR or BDR router that's a fully agents with a non-DR and or BDR routers. Yeah. These two neighbors can exchange hello packet, update, query, reply, and also acknowledge. Okay, full/DR. Yeah, the router is fully adjacent with the indicated DR neighbor. These two neighbors can exchange hello, packet, update, query, reply, and also acknowledgement. Meanwhile, full BDR, the router is fully adjacent with indicate BDR. Yeah. These two neighbors also can exchange hello packet, update, query, reply, and also acknowledgement similar to the similar to the full and /DR. And two-way DR other. The non-DR or BDR router has a neighbor relationship with another non-DR or BDR router. These two never exchange hello packet. The normal state of OSPF router is usually full. If a router is stuck in another state, it is an indication. Yeah, it is an indication that there are problems in formatting adjacency. Yeah, the only one second. Okay, the only exception to this is a two-way state, which is normal in multicast broadcast network. All right. Okay. So the output generated by R2 confirm that R2 has adjacencies with the following routers. Okay. R1 with router ID 111, you can see here, and router ID R333 is a full state, yeah, and the role of RT is a DR, and also with with ID 1111 is a full state, and also and R1 is neither DR nor BDR. Okay, all right. So default DR and BDR election process. The OSPF DR and BDR election is based on the following criteria. First, the router in the network elect the router with the highest interface priority as the DR. The router with the second highest interface priority is become BDR. Next, the priority can be configured by any number, which is between 0 to 255. If the interface priority value is set to 0, that interface cannot be elected as DR or BDR. The default priority of multi-access broadcast is 1. Yeah. Okay, if the interface priority are equal, then the router with the highest router ID is selected. Yeah, the DR. The router with the second higher router ID is the BDR. The election process takes place with the first router with an OSPF enabled interface is active on the network. If all the routers on the network have not finished booting, it is possible that router with a lower router ID become DR at the moment. The addition of a new router does not initiate a new process. DR failure and recovery. If the DR is selected and it remains the DR until one of the following event occurs. The DR fail, yeah, and then the OSPF process on the DR fail or it is stopped, or the multi-access interface on DR fail or is shut down. Yeah. If the DR fail, the VDR is automatically promoted to DR. Yeah, this is the case even if another DR DR other with the higher priority or router ID is added to the network after the initial DRs or BDR election. However, after a BDR is promoted to DR, a new BDR election occur and DR other with the highest priority or router ID is elected as a new BDR. Yeah. Okay. The IP OSPF priority command. If the interface priority, yeah, are equal on all routers, the router with the highest router ID is selected the DR. Instead of relying on the router ID, it is better to control the election by setting interface priority. This is also routed to be the DR in one network and DR other in another. To set the priority of interface, use the command IP or spare priority value, where value is between 0 to 255. The value of 0 does not become DR and BDR. The value of 1 between 1 and 255 on the interface MAC is more likely that the router become DR or the BDR. Configure OSPF priority. The command shows that the command being used to change the R1 G00 interface priority from 0 to 225 and then reset the OSPF process. Okay, here is the step. Okay. Okay, this is some activity and also packet tracer in order to determine DR and BDR. So you can try to assess this packet tracer. All right, so modify single area OSPF version 2. Cisco OSPF cost metric. Routing protocol use a metric to determine the best path of a packet across a network. OSPF use a cost as a metric. Yeah. Spare user cost as a metric. A lower cost indicate a better path. The Cisco cost, yeah, of an interface is inversely proportional to the bandwidth of the interface. Therefore, a higher bandwidth indicate a lower cost. The formula used to calculate the OSPF cost is like this. Okay. The default reference between the default reference bandwidth. Yeah, the default reference bandwidth is 10 power of 8. Therefore, the formula is cost is 100 million bit per second divided by interface bandwidth in BPS. Because the spare cost value must be integer. That's one thing. Fast Ethernet, Giga Ethernet, and also 10 Giga interface share the same cost. To correct this situation, you can adjust the reference bandwidth with the auto cost reference bandwidth command on each OSPF router. Manually set the cost value with the IP OSPF cost command on necessary interfaces. Okay, this is some refer to the table for the breakdown of the cost calculation. Yeah, all right. Adjust the reference bandwidth. The cost value must be integer. If something less than integer is calculated, OSPF round up to the nearest integer. Therefore, the OSPF cost assigned to a giga interface, gigabit, yeah, Ethernet interface with the default reference bandwidth, which is 100 million BPS will equal 1 because the nearest integer of 0.1 is 0 instead of 1. Yeah. Okay. So this is the calculation. For this reason, all interfaces faster than FastNet will have the same cost value of 1 as a fast Ethernet interface. Yeah. To assist OSPF in making the correct path determination, so the reference bandwidth must be changed to higher value to accommodate network with link faster than 10 not 100 megabit per second. Adjust the reference bandwidth, continue. Changing the reference bandwidth does not actually affect the bandwidth capacity on the link. Rather, it simply affects the calculation used to determine the metric. They adjust, okay, to adjust the reference bandwidth, use the auto cost reference bandwidth megabit per second router configuration command. This command must be configured on every router in the OSPF domain. Yeah. Notice in the command the value is expressed in megabit per second. Therefore, to adjust the cost for gigabit Ethernet, use the command auto reference bandwidth 1000. For a 10 gigabit Ethernet, use the command cost this value. Yeah. Okay. To return the default reference bandwidth, use the auto cost reference bandwidth 100 command. Yeah, use this. Another option is to change the cost on one specific interface. Use the IP or SPF cost command. Yeah. Whichever method is used, it is important to apply the configuration to all routers in the OSPF routing domain. The table shows the OSPF cost if the reference bandwidth is adjusted to accommodate 10 gigabit Ethernet link. The reference bandwidth should be adjusted anytime there are a link faster than fast Ethernet, which is 100 megabit per second. Use the show IP or SPF interface command to verify the current SPF cost assigned to the interface. Okay, OSPF accumulate cost. The cost of an OSPF route is the accumulated value from one router to the destination network. Assuming the auto cost, reference bandwidth 10,000 command has been configured on all routers, on all three routers. The cost of the link between each router is now 10. The loopback interfaces have a default cost of 1. Okay, all right. So this is the example. You can calculate the cost for each router to reach each network. For example, the total cost for R1 to reach the 10.10.2.0 /24 network is 11. Okay, this is because the link R2 cost equal 10 and the loopback default cost is 1. So 10 plus 1, you will get 11. You can verify this with the show IP route. Yeah, command. Verifying the accumulated cost for the path of 10.10.0.2/24 network, okay, on R1. Okay, so you can see the information in here. All right, this and also this one. Okay, so this is some good info about this. Yeah. Okay. Reason to manually set the cost value include the administrator may want to influence path selection within OSPF, causing different paths to be selected than what normally will given default cost and cost accumulation. Connection to equipment from other vendor who use a different formula to calculate OSPF cost. To change the cost value reported by the local OSPF router to other OSPF routers, use the interface configuration command IP OSPF cost value, like this example. Okay. Test failover to backup route. What happens if the link between R1 and R2 goes down? You can simulate that by shutting down the Giga Ethernet 0/0/0 interface and verifying the routing table is updated to use R3 as the next hop router. Notice that R1 can now reach the 10.1.1.4/30 network through R3 within a cost value of 50. Okay. Okay, this is an example. Right, hello packet intervals. OSPF version 2 hello packet are transmitted to multicast address 224.0.0.5, means all OSPF routers every 10 seconds. This is the default timer value on multi-access and point-to-point networks. Nodes hello packet are not sent on interfaces set to passive by the passive interface command. The date interval is the period that the router waits to receive a hello packet before declaring a neighboring down. If the date interval expired before the router received a hello packet, OSPF remove the neighbor from its link state database or LSDP. The router floods, okay, multicast or floods the LSDP with information about the down neighbor out all OSPFs enabled interfaces. Cisco use a default 4 times the hello interval. This is 40 seconds on multi-access and also point-to-point network. Verify hello and dead intervals. The OSPF hello and dead interval are configured on per interface basis. The OSPF intervals must match or neighbor adjacencies does not occur. To verify the current configured OSPF version 2 interface interval, use this command show IP OSPF interface. The Giga Ethernet 0/0/0 hello and that interval are set to the 10-second and 40-second respectively. Okay, all right, this is the one. Use the show IP OSPF neighbor command to see the dead time counting down from 40 seconds. By default, this value is refreshed every 10 seconds when R1 receives a hello from a neighboring. Modify OSPF intervals. It may be desirable to change the the OSPF timers so that router detect network failures in less. Doing this increases traffic, but sometimes the need for quick conversion is more important than the extra traffic it creates. Note the default hello and that interval are based on practices and should only be altered in rare situation. OSPF version 2 hello and that interval can be modified manually using the following interface configuration mode. Okay, these two. Use the no IP as usual in order we want to reset to the default value.